Okay, here we go. We have a Tinkercad file. This is phase one of Project Analog Sensor. The goal was to have one LED that maintains its on state and then one LED that flashes. This LED is flashing. This LED is just staying on. Power comes from 5 volts and powers this rail. This LED gets a constant source of power. This LED is powered by the Arduino. It's in the pulse width modulation, PWM. It's got the tilde. It's in the right slot. If we look at the code, it starts off, sets up, and initializes the value at 0, and then does the setup. The setup establishes pin 3 as an output and establishes communication with the serial port at a rate of 9600. In the void loop section, we're writing to pin 3 and we're saying for it to go back and forth between 0 and 256. Then we're saying for it to go back down from 255 back down to 0. So we get our blinking in a different way. This analog is different than the digital. Digital is on or off. The analog lets us go on a scale from 0 to 255, or that's just this case, but it allows us to go and get these graduated values from 0 on up, and then from 255 back down to 0. Thank you for watching. All right, so this is Project Analog Sensors Phase 2. In this simulation, we are connecting an Uno to a breadboard, and the object was to light one LED, have one LED remain off, and then be able to use this photoresistor slider to change the values on the serial monitor. All right, so power comes in through this pulse width modulation pin and powers this, but in our code we're not doing anything there, so that's just going to remain off. We've got a 5 volt power powering the rail. We've got a ground wire connected to the ground rail. Power comes in, transfers over this way into the anode, lights the LED, and then comes through ground through the resistor. We also have power coming this way over to line 23, where it goes and drains to ground through a resistor, also known as a pull-down resistor. We have this photoresistor which measures light, and we have this power. This is power coming in through the anode, but then we also have a analog in, which this transfers information that this photoresistor reads back into the computer. So by adjusting this slider, power comes in this way, and then we get this reading of, on the low end, it looks like it's about 8. On the high end, it's about 765 on the serial monitor. When we look at the code, it's C++ code. This is in Tinkercad, so it's doing Arduino, aka C++. To initialize the value of 0, Then we go into the void setup. We set up pin mode 3 as an output. Then we establish that serial begin is going to happen at 9600. So this is our baud rate. It's 960 characters per second. In the void loop, the only thing that's really happening is that we're reading, the value is analog read at A1. So we're trying to figure out what's going on from the photoresistor at A1. It reads, the computer reads this value and transfers that information to the serial monitor every second. If this number was raised to 10,000, it'd be 10 seconds. If it was lowered to 10, it would be 10 milliseconds. That is essentially what's going on in Project Analog Sensors Phase 2 with the photoresistor. Alrighty, so this is Phase 4 of the assignment. Basically, it's an Arduino controlling 4 LEDs with a potentiometer. Here's the pot switch. Here's 4 LEDs, 4 resistors at 220 ohms, and some wires connecting them to the board. If we go to the code, it starts off, determines the pot pin is going to be A5, and then associates each of the LEDs with these sockets or pins on the Uno board. Goes into void setup, sets up the pot pin, sets up the LED pins as outputs, begins serial monitoring at 9600, and then starts the void loop. We've got the pot measurement being read into A5, and they want it to print to the serial monitor. If the measurement from the potentiometer is greater than 256, we want to light this pin and not these ones. And then it just keeps going down. If it's greater than 512, which would be halfway, it'd be these two would be lit, and then that one, those two are not. If it's greater than 768, on with 3, off with 1. And then if this dial is maxed all the way out to the right, they want to light up all the LEDs. So let's give that a try. Get our serial monitor going. So we got a pot switch. When we turn it all the way off, basically it's like 1, the first LED. And we keep going up, 3, and we max it out. It'll be all 4 LEDs are lit, 1023 on the serial monitor. And yeah, that is basically the assignment. So thanks for watching.